When a proton reacts with bicarbonate, bicarb, proton, it gives rise to carbonic acid, H2CO3, carbonic acid. And carbonic acid has the interesting property that it can dissociate into H2O and CO2. And CO2, of course, you can breathe out. So this is a main buffer system that's in our bodies, right? But the interesting thing is it's an open buffer system because you can adjust this buffer system by adjusting the concentration of CO2. Now you remember from the Henderson-Hasselbalch equation that the pH is just equal to the pKa plus the logarithm of the base over the acid. And in the case of the bicarbonate system, what this translates into is that the pH is equal to the pKa, which for bicarb happens to be 6.1, plus the logarithm of the concentration of the bicarbonate ion that's in your blood over the concentration of the acid. Now, the acid is carbonic acid. But because it's in equilibrium with the CO2, this turns out to equal 0.03 times the pCO2 measured in millimeters of mercury, right? That's the pressure of CO2 in the atmosphere. Crystal? It's a magic number that I told you because I happen to know the equilibrium constant here between CO2 and carbonic acid. So I'm just going to ask you to trust me that because this is always in equilibrium, the concentration of carbonic acid is always related to the concentration of CO2, and since CO2 is a gas, we will measure that as the pCO2 in millimeters of mercury. And it turns out that in a normal person, the concentration of bicarbonate ion in your blood is 24 milliequivalents. And the pCO2 in your blood is 40 millimeters of mercury. And so if I plug those numbers in, what I end up with then is that the pH is equal to 6.1 plus the logarithm of 24 divided by 1.2, right? And this turns out to be 6.1 plus 1.3, which is exactly 7.4, your blood pH. Okay? Does that part make sense? Questions about this part? Now, suppose I say, let's go have some fun. Let's do a workout. Let's have you come up here and do as many push-ups as you can do in 2 minutes. Okay? And then I'll give you a 5-minute break, and then I'll say, now I want you to do as many sit-ups as you can do in 2 minutes. And I might give you a 5-minute break, and then I might say, let's go for a 1.5-mile run that we'll time. Okay? And then we'll see how you feel. Now, how do you think you're feeling at the end of that 1.5-mile run after you just did all these push-ups and all these sit-ups? You breathing normally or are you huffing and puffing? Why? Well, what happened was your muscles generated a lot of lactic acid, didn't they? Okay? And what that meant was that lactic acid consumed some of that bicarb. Okay? So after a workout, in the areas of your muscles had increased lactic acid, and they decreased the concentration of bicarbonate. I don't know what they decreased it to, but let's make up a number. In our example, let's just say it's about 20. Well, what's going to happen? Well, we have to take 20 divided by 1.2 and take the logarithm of that. And I don't know what it is off the top of my head, but I know it's a lot less than 1.3. Right? So what this means now is that the pH is less than 7.4. Right? You're acidotic. So what do you do to compensate? You hyperventilate. You breathe out CO2. And what you're doing when you're doing that is you compensate by decreasing the pCO2. That's you huffing and puffing. Okay? And you might decrease the pCO2 in our example from 40, maybe you're going to decrease it to, I don't know, 35. Okay, who's got a calculator on them? Somebody must have one. Take your phone out, somebody, and calculate for me what is 0.03 times 35. What's 20 divided by 0.03 times 35? What'd you get? 19.04. Okay? So now our pH comes back up to about 7.4. Because as our bicarb went down, we compensated by blowing off our CO2. Does that part make sense? Who here has heard of a disease something that happens to diabetics called ketoacidosis? Well, when diabetics get ketoacidosis, what's happening is they're not able to use glucose, and so they're burning fat, and they're making ketone bodies, which happen to be acidic. So they're dropping their bicarbonate. And what do people with ketoacidosis do? They hyperventilate. They have classic breathing. They're going, and what they're doing is they're blowing off their CO2 to correct their pH. Now, how many people here have ever grown something in tissue culture? Right? That incubator that you've got, what's special about that incubator? It's not just air or oxygen. What else is in that incubator? CO2. Why is there CO2 in the incubator? Because that media you're growing your cells in is a bicarbonate-based buffer. And so you are cheating, and you're using this open buffer system to control the pH of your cells. What happens when you take your cells out and you leave them on the bench while you're changing the media and whatever? That nice red media turns what? Kind of purpley, doesn't it, in front of your eyes? That's because the CO2 is escaping, right? Or I shouldn't say escaping, it's re-equilibrating with the CO2 in the atmosphere, which is different than 5%. And as a result, you're getting a change in the pH. Okay, that's all I want to say about open buffer systems.